Hello, my name is Patrick, and this is my final video for my project where I optimize the transmission gear ratios of a race car. The race car that was modeled in this project was a Formula SAE student-built race car that uses a sequential transmission. This race car competes on cone courses set up in large parking lots or at airports and reaches speeds up to 60 miles per hour. The main goal of these student competitions is to be the fastest around the racetrack, so that is what I'm trying to minimize. Gear ratios can have a big influence on the results of a race, so that is why I chose to optimize it. There are multiple forces that act on a race car while it is driving around a track. There are the aero forces, drag and downforce, and then there are also the forces that act through the tires, forces coming from the drivetrain, the brakes, and from centripetal acceleration. Because my cost function is lap time, I had to develop a lap simulator that took into account all these forces. What my lap simulator does is incrementally steps around the racetrack and analyzes the forces at each point. It then uses these forces to determine acceleration and velocity. There are special things that the simulator has to do in order to function properly, such as determine when to brake and when to accelerate, and also what gear to be in. Once it determines the velocity at every point, it can then integrate to get lap time. There are numerous parameters that have to be entered into the simulator in order to model the race car properly. These include aerodynamic parameters, tire parameters, mass properties, engine parameters, including a torque curve, and the radius of curvature of the track at every single point on it. Once I was able to get my lap simulator to function, I was able to verify that it was working properly by comparing its output with real-world results for a specific racetrack. The results came out pretty close. With a working math model, I was able to start optimizing. The optimized variables include the amount of teeth on every gear, the point at which the transmission changes gear, and the amount of gears that are in the transmission. The amount of teeth on the gears are integer values, which are limited on the low end so that the gears can mesh properly, and at the high end for size constraints. The point at which the transmission shifts up and down are continuous variables, and are limited by the operating speeds of the engine. The amount of gears in the transmission is also an integer value. In order to compare the results to something, I ran the lap simulator using the stock gear ratios, and I also made a simulation that used a continuously variable transmission. The results show that from the first racetrack that I optimized on, almost half a second was saved by using the genetically sized gears instead of the stock gears, but it was beat by the CVT transmission by about a tenth of a second. This might not seem like much, but in real life, the difference between first and second place for this event was only 0.2 seconds. For the other race that was simulated, a different racetrack was used and 14 laps were run on it. This time, the genetically optimized gears saved 10 seconds, and the CVT beat it by an additional 5 seconds. As a reference, in real life, the difference between first and second place was only 5 seconds. I did run the genetic algorithm multiple times for both cases, and in both, different optimal points were given every time. Although the optimal points were all different for every run, the lap times were all very similar, so the function appears to have many local minimums that are all very close to each other. Although the stock gear ratios worked well, the genetically optimized gears did reduce lap times. Is it the global minimum? Probably not. There is no good way to find out for sure. The optimized gears from the first racetrack were fairly similar to the optimized gears from the second track, so it appears that a single set of optimized gears could be used for both. Although the CVT did save time, it will most likely never be selected because in real life they are complex and heavy. Some work that could be done in the future is to make a weighted sum function to encompass all the events in the competition so that total points can be maximized. Another thing that could be done is to analyze more parameters of the race car, such as the size of the aerodynamic elements and the size of the engine.